Hello everyone, and welcome to the series of Epic members new product release series. And today it's presented by Epic, the largest photonics industry consortium in the world, representing 800 members. And 6 of them will present their new products as of today. I'm myself, Ivan Nikitski, the photonics expert at the European Photonics Industry Consortium. And in the agenda today, we'll hear the presentation by Hamamatsu Photonics, talking about gain-stabilized silicon APDs. We'll hear from the SEDI-ATI Fibres Optiques about the reflection probe fiber bundles. And we'll hear from PHABULOuS pilot line about their efforts in micro-optical components. The Jorge, Julian, Sanchez, Martinez from KERDRY will present conductive anti-reflective coatings for ECM shielding management. And the workshop of photonics from Lithuania will show us the femtoglass, the new glass and sapphire dicing laser workstation. Last but not least, the founder of PlanOpSim will show us the advantages of having meta-optic components in your optical system. And without further delay, I would like to introduce you to the first speaker, Luigi Ghezzi, the technical marketing engineer at Hamamatsu Photonics. Luigi?
Yes, I'm here.
Welcome. Whenever you're ready, you can share
the
slide and
my screen.
Yeah, please go ahead.
Okay.
And the floor is yours.
Thank you. Welcome and thank you for the presentation. I'm Ghezzi Luigi and I'm technical marketing engineer for Hamamatsu Photonics Europe. And today I will introduce to you our new gain-stabilized APD. First of all, let me quickly introduce Hamamatsu. Hamamatsu is a Japanese company founded 70 years ago. We are present in all Europe with different offices, and we are world leader in manufacturing optoelectronics components, module, and system. We have more than 50,000 standard products in our portfolio, and we have not only detector but also emitters like lamps, LED, QCL, VCL, and laser. For sure, we have detector like photomultiplier tubes, photodiode single run ray, linear and area image sensor, and avalanche photodiode that are the topic that I will introduce today. We also produce our own camera and optical system, and in addition to this lineup of standard components, we can also provide customized solutions. So please don't hesitate to contact us. Today, I will introduce the APD. This is the classic structure. I will not explain in details how it works, but I want to focalize our attention on one of the key parameters of the APD, that is the gain. In ideal condition, as shown here, the gain depends only from the reverse voltage, but we know that we are not in an ideal world. So usually this is the standard graphs that we have for the gain, and we can see that it depends from the voltage and from the temperature. And this is because basically the explanation is in this schematic figure here. When we have a low temperature, the electron don't have internal scattering, but when we increase the temperature, we have an increasing of the vibration of the lattice crystal, and this means that we have more probability to have internal scattering. So for this reason, basically, we need to compensate the loss for the scattering of electron with an increase of the voltage at high temperature. This is the product that I want to show today. It's the new gain-stabilized APD made from Hamamatsu. In these components, we add the gain, a self-bias generator directly inside the chip in order to have the gain, to keep the gain of the light constant. Thanks to our ability in optical semiconductor manufacturing technology, we are able to build this SBG directly on the silicon wafer and with high precision and high quality in order to achieve a stable operation in a compact size. Here you can find the dimension of the size. Basically, the improvement of these components are here, resume here. Basically, we can use these components without a temperature sensor and without a temperature compensation circuit. And we don't need to adjust each single components for the operating voltage. You can see in these graphs the behavior of the gain. On the left here, it's the standard graphs of the gain for voltage and temperature. And here you can see the new silicon gain stabilized APD from Hamamatsu that have a constant gain. And in these graphs, you can see the stability of this gain respect to the temperature. This is the lineup of the standard product. We have the sensor that are available in 2 different configurations, or we can provide also the sensor with the built signal processing circuit. Also in this case, we have 2 possible configurations with single channel or with 60 channel. In AD, we are able to provide also an evaluation board in order to test the sensor. As mentioned at the start, we are also able to provide customized solution. And also in this case, we can offer some custom option like the different array type, active area, or change the gain. It's also possible to add more self-biased generator in order to have different gain from the same components. And this is my presentation in the 5 minutes. So thank you for listening. If you have any question.
Yeah, thank you very much, Luigi. And so after each presentation, we'll have time for your questions. Feel free to express your interest. And do we have anything? Please, you can just unmute yourself.
Okay, and stop the sharing. Thank you.
Thank you, Luigi. Well, I'm wondering myself, Luigi, like what are the main applications of these APDs you're aiming for? What would be the largest market for it?
At the moment, basically, we think about the LiDAR application because I have not shown it, but I can show very quickly here. The sensitivity of this product, as you can see, is in 800 in the visible range, but close 800, 900. And the compact size and the reduce of electronics helps to have low consumer and compact device. So LiDAR, but more industrial, that usually the APD works well for middle distance, let me say.
Mm-hmm. What is the cutoff frequency again? Or the wavelength? The cutoff wavelength.
The cutoff is working the visible, so from 500 to 1000, but the peak it's at 850. So it works in all the range, depends. For sure, it's better to work on the peak, but it's able also to work at 700, for example, with a good photosensitivity.
All right. Yeah, no, it's just because the LiDAR that would be beyond 900. So
depends from which type of LiDAR. Usually, the more the automotive that have a long distance need to work in the infrared. But when you need to work in the middle, you don't really need to have an infrared, but you can use also the standard LiDAR. If you think about the automatic doors, for example, they can work with this type of sensor.
Okay. Well, thank you very much. That's well noted. Do we have any other questions in the audience? If not, I suggest we pass to the second speaker. Thank you again, Luigi.
Thank you.
And the second speaker, or the 2 second speakers, there will be Hervé Aubé, the business line manager, and Claire Guyonnet, the sales director at SEDI-ATI Fibres Optiques. So please, Hervé and Claire, whenever you're ready.
Yes, so we
please share with us what you have.
Share the screen again. I hope this one. J'espère que c'est bon. Is it okay for everybody?
Perfect. Yes, the floor is yours.
Yeah, okay. Thanks for your attention. Sorry, first, it's our first presentation through EPIC new product release, so I hope this will be fine. So we are here today with Hervé to introduce you our reflection probes for fiber bundles for high temperature applications and mostly above 400 degrees. So I will introduce shortly SEDI-ATI. So we are a French company located in the south suburb of Paris, and we have more than 70 years of expertise in the fiber optics field, with about 50 employees. So all manufacturing is done here. We have 200 square meter facilities with 4 clean rooms and about 8 people dedicated to R&D. We had last year about 10% increase in our annual growth, and we have about 35% of our sales international. We also have ISO 9001, and we have a qualification for medical applications, ISO 13485. Sorry. So just to explain where we are, we address demanding markets such as military aerospace, energy applications, research, also medical application and industrial applications. So in this kind of application, it requires, especially in niche market, to adapt our fiber optics assemblies to different kind of environmental constraint. So our main activity is bringing light into customized, complex or extreme environmental environment. So just to summarize some quick figures of what we call extreme. It can be high temp, low temp. It can be also pressure, vacuum, radiation, high voltage, also some hostile atmospheres such as corrosive, abrasive, and also extreme condition in mechanical constraints for the fiber. So all these are taken into account to bring to the customer the most suitable product adapted to their environmental constraint. And so with all these demands, we've seen that there are lots of requirements for high temp to bring light in a high temp constraint. That's what Hervé will follow.
So we propose a new range of probes, fiber optic probes, for applications up to 400 degrees Celsius, like on-off sensors, timing, where this kind of probe is used for register the rotation or the vibration of the blade turbine engine. Or it could be also application for registered or analysis spectrometry applications in a high temperature environment.
So to just explain the basics of the principle of these fiber optics bundles. So you have 7 fiber, which can be arranged to get 1 fiber for the light source. This is the emitting light, which will go to the samples, and then the 6 fibers will bring the light or the information to the detector. It can be online, on-off sensors, so it detects if there is a samples or not, as Hervé explained already for the tip timing application, for instance. But it can be also the emitting light from the samples, the backscattering light, which can be at the same wavelengths or other wavelengths, which will be bring to the detector. So that's the main principle. And with that, we have developed some solution which can go up to 400 degrees.
So first, we propose a probe with 1/16-inch stainless steel probes connected to the device that we have to detect or not, for example, and 2 kind of legs, one emitting and one receiving, with connectors ST or SMA. And we also propose another design, which is a M4 thread probes, just to thread directly on the panel of the customer to analyze what we want to analyze. Also on the right, you see what it seems like a standard FC connection, but in fact, it's a very customized FC connection because we have 7 channels connect to 7 channels. So this is the smallest connector multi-channels that we could find on the market. We'll see just after why we have developed it.
Yeah. So that's the different presentation that Hervé explained. So the fiber arrangement within 1/16 inch mechanics. So all is 100% inorganic materials and protected with stainless steel materials. It can be for visible, UV visible or near infrared on demand. So we can select the right fiber appropriate to this. Then again, this is the explanation with the M4 thread. So you can fix this with the right thread to your panel. And then this is the explanation how you can arrange this configuration of the Y cable in front of the probes. Means that you can connect with this specific FC connector, the 7 fiber in front, either the 1/16 inch probes or the M4 thread probes.
Absolutely. So the emitting is connected to the emitting, and of course the surrounded fibers are connected to the receiving.
And all these assemblies, so we will not disclose the process, but is assembled to meet high temperature up to over 400 degrees. So that's the challenge. So there is 2 challenges: the connection with the 7 fibers and the high temp. And then what else? Beyond 800 degrees is our next target. And also there are some options which is already available for 400 degrees with a 90 degree angle. So means that if you have to come within a very small area where you have the constraint of high temp, we can fix the 7 fiber 90 degree angle within the mechanic.
So these probes could be straight or could be also proposed in a 90 degree angle. And of course, the version with 800 degrees C will be proposed on straight and on 90 degree.
Both versions. So it's under test right now.
Thanks for your attention.
Thank you very much. And if you have any questions, we're here to answer.
You can see there the next probes that we are working on for 800 degrees C. This is the prototype. Thank you.
Mm-hmm. That's impressive. Thank you, Hervé, Claire. Time for questions. Anyone who needs very stable fibers? Udo, please.
Yes, Claire, I have just a question. Did you consider also multi-core fibers instead of the individual fiber arrangement?
No, we have not been asked for that, and I'm not sure multi-core fibers.
No, right now we're working with single fiber arranged in bundles.
Yeah.
It's probably a low cost.
And not only, it's also due
choice.
to the fiber which also needs to handle the high temp. So you need to select fibers which are appropriate for that. And I'm not sure that multi-core fibers are available with different coatings.
I don't know.
That is more the fiber design itself, but the fiber core, the fiber material would be the same. So maybe it's an idea to consider for the future.
Yeah.
For a straight version, it would work, I think. But for an angle version, I think it not works.
Okay, thanks.
It's always compromise.
Okay, Jorge, go ahead. Just unmute, please.
Okay, thank you. Just a question is, do you perform any coating, any treatment on your interfaces, especially for high temperature?
No. The problem of the special coatings at the end of the fiber, it's deposed by temperature or temperature chamber or vacuum chamber, and this kind of coatings will not go up to 400 degrees or more.
It depends on.
It's not suitable.
Because, for example, DLC-based treatments go well beyond these temperatures.
Yeah, I heard about this, but we are not equipped by.
Okay, just I enjoy and I go in advance. We can provide something about this.
Okay, so please send us your presentation and we'll have a look at that.
You will have it later on in a couple of minutes.
Yeah, it's coming in a minute.
Okay, great.
Thank you.
Thank you.
Thank you.
Okay. All right. So any other questions? If not, let's thank the speakers again. Then we move to the third presentation given by Jessica Van Heck, the Managing Director of the PHABULOuS pilot line. Jessica, whenever you're ready.
Okay. Just presentation mode, so all should be good now. And yeah, so today I will be talking a little bit about the funding opportunities that we have for the services towards the implementation of freeform micro-optics. And let me start with a short introduction. So we are part of the PHABULOuS project, which is a European funded project in the Horizon 2020 program for the manufacturing of freeform micro-optics. And as part of the project, we want to create an entity to be the single entry point and also to continue the services beyond the project. So the project is coordinated by CSCM and I am the managing director of the association. But of course, very similar goals. And one of the main goals is to create this pilot line for design and manufacturing of freeform micro-optics. And the idea is really to unite Europeans, leading organizations, so RTOs, industrial partners together into one pilot line. So these are the partners that we are working in, both in the project as well as in the association. And as said, very much focused on freeform micro-optics. So taking the advantages of freeforms, but miniaturizing that to the micro scale. And you see that you can have all kinds of different structures. And we've seen also that the amount of patents and the amount of publications that are involving freeform micro-optics is exponentially growing. So this is also one of the reasons why we started PHABULOuS. And I will explain a little bit more about why, but to give a first introduction, I will show a short video.
Freeform micro-optics have the capabilities to revolutionize industries. Imagine automotive lighting that is perfectly aligned with the design of the car, or lighting solutions that provide better energy efficiency, better light distribution, and perfect aesthetics. Imagine all AR and VR capabilities with better resolution, feeling more realistic, yet the device reduced to a size that you don't even realize you are wearing. Or improving your home with luxury and smart windows. That is the power of freeform micro-optics. The ability to create optical shapes in any form you want, completely miniaturized for perfect integration. Opening up new opportunities for security and branding, optical communications, consumer electronics, and more. And now imagine that this can be done with equal or even better specifications than conventional systems, and at lower costs. This is why PHABULOuS has opened up the one-stop shop in freeform micro-optics, making this technology now easily accessible to everyone who wants to implement it, proving a full supply chain of world-class freeform micro-optics specialists. We can take you from design to prototyping and into pilot production. For full product lifecycle, including design, modeling, origination, tooling, and manufacturing services. Some have already paved the way by integrating freeform micro-optics into their product portfolio. Are you ready to take the next step in your product development? Make it fabulous. And contact the one-stop shop for freeform micro-optics at info@fabulous.eu. We are fabulous.
So I hope that gives a good idea on what we do. And so you've heard already, so there are quite a lot of technologies involved. And this is one of the reasons why we've set up this pilot line. So instead of going to all these individual companies and finding one that can help with design, one originator, a tooling company, a replicator, a company that can help with integration. So you can do that all through Fabulous. And we offer all these services through a single NDA and a single service contract. So, and of course, all these services should lead to products. And I think that's also the new in this new product launch. So what I wanted to share with you, we started the project with 5 companies that wanted to integrate freeform micro-optics, and we now have the results available. So, I mean, there are many different applications, but you see here some of the companies that we've been working with. I will show them quickly. If you have any questions, of course, I can explain a little bit more about that later. But one of the companies is Hella. So they are working, they have been working with Fabulous on their next generation headlights using freeform micro-optics to create a really small system that can be used for automotive headlights. And you can see here some of the images of some of the optics that we've made. We've been working with micro OLED, so they have a brand called Active Look, which are sport glasses that are utilizing augmented reality, so you can see how fast you are going and how much kilometers you have done already, height differences, etc. And so they use a micro OLED display that uses the freeform optics to display it on the glasses, and they want to enhance the brightness, and therefore they've been working with Fabulous to create optics for this. So this is one of the cases. So you see here also some of the things that we've done. Then Seisenbacher for the interior transportation lighting. So really creating a smaller form factor luminaire that uses less LEDs, but still has a really nice uniform light distribution. Swarovski, really nice to have them on board as well. They, of course, understand everything about crystals, and so they've made a design based on the crystal facets that we've replicated using UV imprint technologies. And you see on the right image at the bottom that if you use a coating, you get a really nice sparkling effect on the foil itself. And in the big picture on the right, you see the sparkle if we put that foil in front of a luminaire. And it's really a nice sparkling effect. So this is one of the things that we've done with Swarovski. And then another one is Zoomtopol. So with them, we've been working on wall wash applications and make sure that we get a nice uniform light distribution from these systems. Then there was one more company that initially started in Fabulous. They were purchased, and so we weren't able to finish it. But I think it's really nice to show that we have some really nice capabilities also in the VR. So using freeform micro-optical components to create micro lens arrays that have individual freeform lenses can allow you to make really small form factor headsets that still have a really wide field of view and a high resolution. And some other examples just for inspiration before I tell a little bit more about the funding opportunities. So maybe you've seen the light carpets, of course, that's coming from one of our partners, is a nice example of freeform micro-optics. And then also in the optical communication, we have one partner that has been working on ways to do automated fiber coupling using freeform micro-optics. I think is also a very interesting application. So what we offer right now is this easy access to the full value chain, these manufacturing services, yes, from prototyping to piloting large volume production, even the design. If you feel it could be a solution, then we are more than happy to help you. And so we are here today also to explain that we still have this open call running. And there is up to 90% of funding available for European companies that are looking to implement freeform micro-optics. So you will find all the information on our website under the tab Open Call. I will show you already a little bit of the information. So as I said, 90%. So that's for the micro SMEs with less than 10 employees. But even up to 3,000 FTEs, you can still get up to 50% of funding. So quite some interesting opportunities, I would say. So if you are looking to consider applying, that can be for any individual service from design to origination to replication or full pilot production. And once you submit a proposal, we will evaluate that on 3 criteria. So we really want to see the excellence. So how we are not funding commercially available optics. We really want to see that you are working on something new and unique in the market. Then the impact. So we would like to have at least the concept of volume production. For instance, the ARV market, of course, the volume is not there, but we all know that it will hit volumes at some point. So we would like to see, kind of the idea behind in the go-to-market strategy. And then the implementation. So that's really the services that you would like from PHABULOuS and what you would be committing yourself. And then the application process is fairly simple. So you make a proposal, you can download a template. Every end of the month, we will evaluate the proposals that came in. And then once it's evaluated positively, we work together on the final project plan. And then the execution typically takes between 6 and 12 months, depends a little bit on the extent of the services that are requested. And then, of course, also some sense of urgency, because this call is only open until the end of the year. So that means that with us being already in June, I would say we have a little over 6 months to go. So if you have any ideas and you would like to talk about it, and we would love to help you also make a proposal, this will be done then by me and Ton. So I'm the managing director. Ton is the technical coordinator. So especially after an NDA phase, he will get involved, and he knows a lot about all the technical capabilities of our partners. And with that, I want to say thanks to all our project members, to EPIC for having us at this meeting today, and of course, the European Commission and Photonics 21 for providing the funding. And I always end with micro-optics is fabulous. So thank you for your time. If you have any questions, let me know.
You're always welcome to join, Jessica, and we're always happy to hear about PHABULOuS. Do we have any questions in the audience? Anyone that wants to do a project with micro-optics? Jessica, do you have any maybe success stories already to share from the companies that came to you and managed to have their project successfully scaled up?
Yeah, so those I just presented a little bit. So those are like the first results. We are working now on the first pilot cases. So the people that have already submitted. But we've not been sharing any details about that yet. But I would love to come back later and share some results on those.
Okay. That's very promising still. Anyone else? If not, I suggest we thank Jessica again, and we switch to the next speaker, who is Jorge Julian Sanchez Martinez, Sales and Business Development Senior at KERDRY. Yeah, please unmute, Jorge, and whenever you're ready.
Can you hear me?
Yeah.
Okay,
yes.
The screen is there, no? Okay, thank you to EPIC for hosting this amazing event periodically. This is also our first time, so we hope we fit with your expectations as well as organizers and coordinators. As said, my name is Jorge Sanchez. I am the Business Development and Sales Senior in KERDRY. We will explain it in the presentation. We belong to a bigger group coming from the automotive sector based on a strategic decision briefed later on. It doesn't work. Okay, so my presentation would be, I will introduce, as said, who is the HCF group and KERDRY, its added value, and basically our technical introduction for the ITO coatings we propose. Okay, this is basically the presentation. A brief, we are basically, as KERDRY, located in Brittany, in Lannion. The former company was established in 23. coming mainly most of the founders, two founders initially, and most of the equipment initially came from the former France Telecom and Senet in the area, and we are obviously in the so-called and recognized French, the so-called French optical photonics valley, okay, in Brittany. We have right now more than 15 PVD machines. Our expertise, technical expertise, is PVD techniques, coatings, both electric, dielectrics, and mixing both at the same time, which provides the ITO conductive coatings we will brief here for you. Okay, all these machines, all variant technologies included, EAD, electron beam, etc., in more than 1,000 square meters carré of clean rooms ranging from ISO 5 to 7. We will show later on that the technology, the heart of the technology in the whole HF group is PVD. So in total, with our machines, the whole group, HAF, is more than 35 machines worldwide, mainly 15 dedicated to optics. Our treatments comes from UV up to IR long wavelength, up to 20, from 350 more or less up to 20 microns. Okay, capacity of substrates, not only 2D but as well 3D for luxury, for example, as well as explained before. But we go from less than 1 inches wafer, for example, up to 55, and in process of certification up to 70. This is for astronomical applications, as you can guess. As well, since we provide selective pattern coatings services or proposals, we have a UV-based photolithography infrastructure up to 8 inches. We can treat, we can manage, whose average resolution of the patterns is well below 1 micron. Okay, HEF at a glance. It was created in 1953, coming from tribology. Initially, after the end of the World War, one of the main issues appearing in technology at this stage was friction, tribology. And since automotive was highly ramping up at the age, this was the main business line at the beginning. We are worldwide, more than, in fact, today, more than 86 industrial plants spread in more than 21 countries. In 2021, the whole group took more than 300 million turnover, with the specificity, one of our first specificity, more than 10%, almost 20% of our resources are invested in innovation. We finance our own innovation. This is based because in our heart, our conception of business, it's a vertically integrated model, from idea up to solutions. Okay, as explained here, basically. But again, once more, the key of our technology is PVD techniques, coatings. So as said, as exposed before, we come HAF group from tribology, and these days, due to the economical challenges, a diversification strategic decision has been taken in the group. One has been the creation of technologies for hydrogen, green economy, and the other, photonics. Photonics has been created the business line for pure acquisition. 5 French companies divided geographically there. We are KERDRY, in Brittany, as said before, and one American company. This one is mainly related to glass high surfaces coatings. Okay, so as you can see, we are more than 22 persons, 25, 26 today, in fact, in KERDRY, and our specific added value again is PVD technologies for coatings, both metallics, Again, metallics, dielectrics, and a combination of those if ever necessary. Okay, you know more or less where we are, who is KERDRY, where it comes from. Some market figures based on numbers of 2022. Currently our main market is in industry, instrumentation mainly, with 3 strategic sectors that have to be increased up based on our business plan, and where our conductive ITO coatings are the head of this development. Defense, our strategic position should be increased in defense, security, aeronautic, and space. Okay, some numbers only for KERDRY. Our turnover last year was a little bit more than 2 million euros, slightly above. But what is very important is an EBITDA of 2 digits, and with an expected on average growth more than 100% from this year up to 2028. Basically, right now our sales geographical distribution is mostly in the European Union and something in America. And our strategic plan is to reinforce our European leader position and to further penetrate the American one. Okay, a rough introduction of what we can do, apart from make treatments of typically black mirrors, etc. Everyone may be concerned, including, and this is important, based on the previous presentation from SEDI. We treat, this is one of our specific added values as an optical industry. We can treat many types, all types, in fact, of fibers, even for harsh environments, make the selective filters or anti-reflective coatings at the edges of the full fiber, okay? One of our more innovative products is electro-optical filtering, multi-zone filter ones for space applications, okay? We are about to launch highly selective filters whose bandwidth is in the range of 10 nanometers with high rejection level from near infrared up to almost 2.5 microns. We can treat in our in-house not only hybrid pattern monolithic elements, but also a whole multi-zonal array photolithography, monolithic and hybrid, sorry. Okay, at the moment, promising results, conducting us to perform right now, at the moment, environmental tests to assure space qualifications, real ones. Okay, ITO, the harsh conductive treatment we want to show. Basically, ITO is the acronym of indium tin oxide coatings. Okay, applied in-house on a variety of substrates, including glass and even plastics, all forms as said before. Our main applications are the one indicated there, RF shielding or protection against electrostatic discharge, as well as heating ones. Heating is very important for windows, for example, in this plane, who is a Bombardier. Bombardier was with us, and this is just mainly to avoid condensation of humidity or for the atmosphere. It's just you make you warm up based on the conductive coating. You warm up the surface, and the surface condensation is minimized. Okay, we preserve the figures of merit that marks state of the art in this technology. Which basically is summarized here, optimal transmission well above 80% in the visible up to 1.5 micron range. We can also, for other similar applications, mainly in defense and avionics, we can propose a conductive bus bar, as an option in our coatings, as the one shown in the first photo on top. Basically, just to introduce you how this technology may work. Basically, sorry.
Excuse me, this is Ivan speaking. We still want to leave a little bit of time to have a questions for you. So please.
Basically, we study. We are competitive as metal grids, even because we are less expensive and easier to treat and to propose. Coming up soon as developments is to increase conductive properties, basically for space defense applications and CL bands for telecoms. Our proposal is delighted, based on our experience, to listen to your requirements in order to propose and to improve your optical systems in the applications initially envisaged. So, just to propose the visit of our facilities for those who decide later in-house, okay? And that's all. If you, after this, you can think about, you may have a doubt or a proposal for us. We are delighted to discuss with you directly. It will be the whole week, in Munich, in the booth shown there. Delighted to show there and to have discussions for business of mutual benefit. Thanks for this opportunity on behalf of KERDRY again, and thank you, EPIC, once more for the opportunity.
Thank you, Jorge. We have time for just one quick question. Anyone? Well, Jorge, you're present in so many markets. Is there one particular one where you would want to expand?
Yes, I try to show it. Our strategic decision is to expand in aeronautics, on flight space, because we are on ground very strong. We have a very strong position on ground space applications, but we are going to increase our position in space defense and aeronautics.
Okay. Well, thank you. I'm afraid we're running out of time, so I'll pass now to the next speaker then. Laurynas Cekanavicius, the head of product development at the workshop of Photonics, will present us the femtoglass.
Hello, everyone.
Hello.
Share the presentation. So I'm very glad to have this opportunity with you, everyone, to share our newest industrial solution for brittle materials dicing. So let me just jump to the video to show what we are doing and explain further into this presentation in detail what kind of new capabilities we are introducing into the industry. So let me just go with the video. So to recap, what we saw is laser dicing machine for glass and sapphire. It's actually versatile tool to reach capabilities of femtosecond lasers in order to separate brittle materials, having capability to singulate structures not only in circular manner but or square, which is common and currently in the industry, but actually to have full capacity to work with all varieties of pieces separation in irregular shapes. Uniquely, we have all capabilities in single machine to work with ultra thin glass, which is normally down to 30 micrometers, to understand the scope altogether to 10 millimeter range in one industrial solution. It is in-house developed technology, which is patented and actually leading currently in the market, which is used for a variety of applications and has tunability in single device. So what actually this machine has inside itself and what is new there is we actually have automation ready design, fully integrated not only with laser dicing, but with a thermal separation process, which is letting you to avoid having additional tool for mechanical braking. We have integrated metrology inside the machine, so you can actually inspect the pieces that you are cutting with the laser, as well as have alignment and automatic sample recognition capability to simplify operators' daily work. And moreover, we have, of course, extraction unit to extract the particles which might be generated during the process. And current design is capable to machine up to 8-inch wafers, but we also have design ready for new industrial standard to machine 12-inch wafers as well. So here in the pictures, you see the quality of diced sapphire pieces, as well as fused silica glass and boreflow glass as well. So actual quality which is achieved is roughly down to 10 micrometers chipping, and overall quality and accuracy of around 1 micrometer. These are scanning electron microscope photos to show the practical edge cutting quality, which we are capable to demonstrate within this industrial solution. Compared to other available technologies in the market, for example, laser ablation or blade dicing, we have way higher speed compared to capabilities that are conventionally used for production nowadays. And we also have way better quality compared to other methods which are introduced nowadays. No water or dirty process is involved. So our customers can actually work with newest investments in the technology to have clean substrates after the process. Technology is applied to a variety of applications which are still emerging. For example, virtual or augmented reality glasses might be a very trendy application to have in mind, going all the way back to consumer electronics, display technologies, generally micro-optics or microchips singulation, as well as general just glass wafer or sapphire wafer dicing. So who is not familiar with our company in general? We are ultra-short pulse laser solutions providers to the industry. We have our laboratory in which we are developing unique technologies to have the newest advancements to be introduced into the industrial market. And we are nowadays still carrying R&D studies to have the prototypes machined in-house. So we actually support our customers all the way through the path. We started by laser system solution. We actually have capacity to show proof of concept and make your prototype to show this technology capability to you. and we can also scale your production prior to installation of the laser system inside the factory to actually give you the first spaces to introduce your product to your customers and actually boost your business prior having the laser system in your facility. So briefly, thank you for your time today. I hope to have questions. And we are, of course, going to be in a Munich show. So whoever wants to get to know us or to learn more about our new solution capabilities, or just discuss, let's talk in Munich, or you can approach me directly. The contacts are, of course, in the screen. Thank you for your time.
Thank you, Laurynas, and looking forward to see you in Munich indeed. Do we have any questions? Jeremy, go ahead.
Yeah, thank you very much, Laurynas, for your presentation. Really interesting. And maybe I missed the information, but can you tell us more about the speed of this process in terms of quantity, in terms of speed? Do you have any information?
Yeah. So we have in this machine capability to, in single pass, dice up to 2 millimeters thickness glass, and maximum speed is approximately up to 800 millimeters per second in single pass. So if you are working with thinner glass or sapphire or other material, the maximum speed is at the same level. And if you're working with thick material, so 10 millimeters, let's say, the speed is a bit, overall speed is a bit slower, but nearly 1 meter a second. This is the number I would go.
Okay, thank you very much. Really interesting for your VR and also consumer electronics application. Thank you.
Sure.
All right, we have only a few minutes left. If there is no further questions, I'd like to thank Laurynas again, and we pass to the last speaker of today, Lieven Penninck, the founder of PlanOpSim, will tell us about meta-optics.
All right, thank you for the introduction, Ivan. Indeed, I'm Lieven Penninck. I'm here to introduce to you today the PlanOpSim meta-component ray tracing interface to Optics Studio that we will be releasing soon. Many of you will have heard about meta surfaces as a new way to use nanostructured optics to create new optical functionalities. PlanOpSim's mission in this growing industry is to provide R&D engineers and scientists with the tools to unlock this technology in the most user-friendly way. And we do this by the computer-aided design software that we have developed, as well as by providing design services to companies and research teams all over the world. Our tool is able to calculate from the sub-wavelength nanoscale onto components of many millions of nanostructures and down to integrating with systems. We are based in Belgium, and we can support the whole design workflow of a meta surface with our team, going from concept and feasibility analysis to modeling the system in ray tracing or with other third-party tools, and then connecting into our PlanOpSim CAD software, which can model the nanostructure and inform the system design of the nanostructure's behavior, down to making libraries of components and multiple components consisting of several nanostructures, which are then validated in the software calculation and can be sent to GDS or other formats for fabrication later on by your labs or by partners. Our tool was developed with the support of IMEC and VLAIO and has been on the market since 2021. You see here some of our satisfied customers on the left, as well as some of their responses after using the tool directly or in a beta test. They confirm that it's a very intuitive tool to use. It's the appropriate tool for designing meta lenses and meta surfaces, and it really saves them a lot of development time. To give you a little bit of an anecdote, typically designers will spend many days just setting parameters and optimizing things. When we do a customer demo, we can actually get from scratch to first meta lens GDS file rolling out within the hour. We believe our tool is uniquely tailored for meta surfaces compared to other simulation tools that you might know. It's available for both simulations locally or on the cloud. It's very intuitive, as also our users confirmed. We can do large area simulations up to 3,000 times larger than with conventional full wave tools, integrate to ray tracing. We can script, we can export this to manufacturing, we can cover the whole meta surface workflow, and we have a dedicated support team of experts on meta surfaces. We can achieve all of this by applying the right calculation methods, full wave calculations, physical optics, and ray tracing at the right scale. And with that, I'd like to move to what's new in our tool. Since this month and this year, we follow a cycle of continuous improvements to the software that are being released. We have expanded the maximum simulation area up to 170 million nanostructures being calculated. That's about 3,000 times larger than with a full wave tool that's possible. We can batch select meta atoms and optimize for angles as well as spatial coordinates. And in the next week, we will be releasing the beta test for an interface to system design from our wave-based solution that will work via a direct export of a DLL plugin, working in a straightforward way that can support design of hybrid meta systems, so combining classical optics with meta surfaces, is able to do dispersion and angle dependent engineering of meta surfaces in both sequential and non-sequential ray tracing. I would like to show you a little bit about how that would work. Within the PlanOpSim software, a user is able to design the meta surfaces, then compose them in what we call PSRT file, and then export that straight into DLLs for design in ray tracers like Optics Studio. You see it applied here, and then the ray tracer calculates the meta surface. In this example, it's just a single meta surface acting on its own, but we can then take the next step, which has been missing up to now in meta surface design, which is to be able to integrate with systems. So we were inspired by this paper here, doing special color filtering for more efficient and better sensitivity in images. Starting here from a telecentric design, we then design within PlanOpSim a wavelength multiplexed meta surface that splits blue and red light top and bottom, introduce that into the meta surface, into the system, and simulate it like this. This is a capability that hasn't existed before in optical modeling, as far as we know. And with that, I'd like to invite all of you to come join us in beta testing this product and make it even better. Thank you very much.
Yeah, thank you very much, Lieven, indeed. Very interesting. Do we have any questions in the audience? In the meantime, I wonder myself, so what's the model to distribute the solution?
The software is available either as one-year licenses or permanent purchases, either to use with cloud calculations, so then your computer is not burdened at all, or you can run it locally on your own infrastructure.
Okay, okay. And do you have any special offers, for example, for academic institutions as compared to companies?
Of course, academic institutions get special discounts compared to companies. We can always discuss about that if you like.
Yeah. Is many of your clients now in academia? Because I can imagine that would be very...
we see both companies and academia. I cannot give you detailed numbers about that right now.
Okay. Anyone else? Oh, it's also we're hitting the limit now of 1 hour that we had for this event. So yeah, I thank Lieven again for this great presentation and also all the speakers of the session today. So right now you have this poll for the event just in front of you. So you will be very welcome to fill it in. Just to say a few more words, so this event was presented to you by European Photonic Industry Consortium that is there to support you in technology and market networking and mentorship, HR support and investment. This is the event of today is not the last of this season. There's still a few activities to do before everyone goes on vacation for summer. Already next week we're going to the Canada with a delegation of EPIC members, and then we're hitting the Laser World of Photonics shows, which is very big for the EPIC members. We'll celebrate there the 20th anniversary of our consortium, in fact, and we'll run 4 different events. One on micro-optics, one on ultra-fast laser processing, and one on PIC packaging and post-processing. You're very welcome to join all of them, and as well as the exhibitor breakfast for CEOs of EPIC members. Apart from this, we'll continue the series of the online meetings. The coming one will be devoted to the sustainable photonics, and then next week we'll hear also about agriculture and laser welding photonics. We will follow up in July with the online technology meeting in photonics for wearables, and then we hit already September that will start with an EPIC meeting for the HR work group. And with this, I thank you again for finding time to join us for this member new product release, and stay tuned with EPIC. Thank you very much. See you on the next occasion.
So thank you and goodbye.